Hi, and thank you for tuning into this very special treat. Okay, what's the special treat? It is an integral I'm going to give you. Well, what else were you expecting? Come on. Right, this is the integral I'm going to give you. Okay, so I'm going to ask you to integrate e to the x sine x. Okay, e to the x sine x. That's your special treat. Okay, do you want to pause the video maybe and just have a go at that? Okay, and see how you get on. Then unpause it and then just yeah, we'll talk about it. Okay, right, that was just in case you thought, no, I'm not going to pause that, I'm just going to watch what happens. So, you know, I knew there'd be people like you watching, you know. Some people have paused it, worked it out and thought about it, and some people have been thinking, right, what's the answer? Some people are like, come on, what is it? What is it? No, I want to make you wait a little bit, okay. Well, what have you tried? I didn't give you a method, did I? Okay, didn't give you a method. Is it an inspection question? Not really, no. Unless you've seen the answer to it, of course. If you've seen the answer to it, then yeah. But no, it's normally you expect some sort of method. Substitution, maybe. But what are you going to substitute in? The difficulty there is you've got e to the x and sine x. They are two completely different functions, aren't they? No. By parts, yes. By parts, okay. That would be a good way of starting it. So what would you have tried? You'd have tried u is equal to e to the x and dv dx is equal to sine x. Yeah? Or maybe the other way around. To be honest, it does not matter. Does not matter. Okay? You might be thinking, why does it matter? Well, you'll see. So, following this through, you'd have du dx is equal to e to the x, and v is equal to negative cos x. Yeah? Good. And then what next? So that means our integral is going to be uv, so that's negative e to the x cos x, subtract the integral of v du dx, so that's going to be positive e to the x cos x dx. Yeah, and did you get that? Or something like that? You're not wrong. You're not wrong. Some of you might have got to that and thought, oh yeah, I know what's going to happen. You've seen it before, that's why. Others would have got to that and thought, well, hang on. Why is that completely different from this? If we can't do this, how are we supposed to do this? Well, you just go with it. If you stop there, continue please. If you didn't get to that, why not? Right, continue from there please. You thought I was going to start, didn't you? No. I'm going to stay a bit longer. Of course, I'm not going to start. I'm not taking my lid off my pen, have I? Okay? You're waiting to take the lid off my pen. Like that. But I don't want to start yet. Have you had a serious think about it? Have you? Have you? Alright, I trust you have now. Okay. Hey, I've started writing. Okay, so negative e to the x cos x. And then this. So what did you do for this? Well, I'm hoping you use by parts again. Okay. Do it in a similar way. Be consistent. Remember, I talked about consistency in previous lessons. So what you want to do is have u is that and du dx equals that again. So I may as well just keep that working there, yeah? But this time you'll want to have du dx as cos x. So maybe, I'm just going to rub this off because you've seen that for plenty of time now, haven't you? I'm going to get rid of that. Okay, and I'm going to put in cos x, there, and then the v will be sin x, won't it? Okay, and then you've got plus uv e to the x sin x, subtract, bit of a squeeze, isn't it? V du dx e to the x sin x dx. Yes? Good. Think about it for a little while, please. Why am I happy with that? Some of you would have got to that and thought, no, that can't be right. Yes, it is right. Hey, got you again? No. Alright, no, let's be serious now, okay. What are you going to do with this? You might think, well, hang on, this is going to be one of those eternal loops, isn't it? Oh no, this is going forever. Mr. Brown's given us a question that's got no end to it. Can you imagine that? Doing maths forever. Yeah. I don't know how I feel about that. In some ways, yeah, it's kind of exciting, but in other ways it's like, yeah. It's kind of nice to sort of know that your problem you're working on has got an end to it, isn't it? Okay. There's something nice about having a finiteness. You know, like when you're really, really young and you go on a long car journey, it's like after about 10 minutes, you're like, oh, are we there yet? You know, and then when you sort of, now you're a bit older, like after about half an hour, you're like, oh, are we there yet? When you're the driver, it's easy because you know when the end is. You might have your GPS there telling you when it's going to be, you know, over, or you know the route and you know how many more turns you've got to go and so on. But when you're a passenger, it's like, oh, how long does it go? There's something about the nature of finiteness that we like. Okay? It's like this whole situation with the confinement coronavirus, okay? Because the end is not yet in sight. People are a little bit unhappy with that. Okay? But as soon as we start to see the end in sight, I think people will start being a lot happier. As soon as there starts to be a drop-off in the number of cases and so on, people start being, so something about that, isn't there? So I can understand when you get to this, you might be thinking, I can't see the end here. You know. Don't worry, I can link maths to just about anything. Okay, yeah, I've linked maths to the coronavirus several times already. Yeah, don't worry, do not worry. That is the same as that, isn't it? Yeah? Sorry, my Essex accent has just creaked out. Okay. It's probably this isolation. I don't have access to the outside world, and my voice is like getting back to my Essex roots. So yeah, so that's the same as that, isn't it? Okay. Now, what did I do here? There's a reason, folks, a reason why in the first, or one of the first videos I did, I introduced the letter I. It wasn't just to be short for integral. Okay. I did it specifically for this question here. Okay. So I've been waiting for this moment for a long time. Okay. I could be like Blofeld, couldn't I, with the pussycat. It's like, yeah, I've been waiting for this moment a long time. Here we go. So I've called that I, didn't I? So let me just write this here. That would have been a almighty clue at the beginning of the question if I've written I equals that. Because do you know what I'm going to do now? I'm going to write I equals that, but also this is the really, really good bit. The really, really good bit. I'm going to write that as I as well. Can you have a think about that? Yeah. That's long enough. Do you see what we've done there? Because that integral was the same as that, wasn't it? Okay. You think, oh, okay, this is interesting, this is new. Yes, yes. This is great, isn't it? Integration. There's always something new to excite us again. We want to work out what I is, don't we? We want to have I equals that. We're going to put on the other side. It's an equation, isn't it? You can rearrange this equation. You can put things on different sides. We're going to put that onto that side. If you didn't think about that, maybe just do that now and I'll wait for you. Okay, did that? So I over there, so 2I equals, I'm just write this a little bit better, okay? Do you mind if I factorise it? I can't hear your response, and it's not as if you could say no, is it? Or yes, as if you can say no, please don't do that. Yeah, so I'll just written it nicely, okay? E to the x, sin x, subtract cos x, okay? Yeah. So, I equals, put this into that, so now the 2, 1/2 e to the x sin x minus cos x, okay? Is there something missing? Of course, whenever you integrate, there's always a plus c, isn't there? Okay, there's always a plus c. Where does the plus c go? You might think, ooh, this is interesting. Where's the plus c? Because you don't really have a plus c until you've done your final integral. Well, certainly it needs to go here, doesn't it? In our final answer. Okay? And you could then say, well, actually, shouldn't it go here as well? Okay? No, you don't really need it there. Okay? I certainly should not put plus c, because if I divide by 2, that's going to be plus c over 2. So I'd use a different letter. Okay? You could say, well, maybe once the integral sign has gone, you put in the plus c. Okay? Well, the integral hasn't really gone, is it? It's still there. So no, I don't really need it in that line. Okay? As long as you put plus c right at the end, that's the main thing. Okay? And there it is. There it is. No, that is maths being absolutely beautiful, wonderful, difficult, crazy, hard, all at the same time. Okay? You got this, which starts off being something that you think, oh, this is really difficult. At some stage, people are like, this is going to go on forever. But look, forever does not have to take that long, people. And it's all about perspective, okay? It's all about perspective, okay? If you think it'll go on forever, yes, it probably will. If you find a shortcut, if you find a way of doing it more simply, more quickly, then no, okay? This is your solution. And that is a lovely, lovely question, okay? It's not in your textbook. I had a good look for it. If you found it and I missed it, please do tell me, okay? I like to know these things, but I couldn't find that in your textbook. Consequently, it's unlikely to be in the A-level maths exam, okay? Further maths students, you have seen this. You have seen this, okay? Several times as well. And yeah, it could be in a further maths exam. Probably could be, should be. I'd put it in there because it's such a great question. Okay. Yeah, so our answer to this is half e to the x sine x subtract cos x. Okay. Yeah. Yeah. I'm just going to rewrite the question now because this is a special video. I'll just check it's still recording because I would hate it if this video stopped halfway, given what I've done. Yes! Still recording, still recording. It's great. So, look, do you mind if I just get rid of all this stuff here? Erase this wonderfulness. It's a shame, really, because I kind of like all this lovely working. It's kind of beautiful, isn't it? Yeah. Okay, so I'm going to put the answer here, half e to the x sine x minus cos x plus c. Squeeze the c in there, like Batman and Robin. Robin's always trying to squeeze into the scenes. Of course, the film's all about Batman. People go to the cinema to watch Batman, and Robin just tries to not even blend in, does he? With that stupid mask. I mean, Batman's got a proper mask. He can't. But Robin, I mean, look. If I did this, am I completely unrecognisable? Do you not know who? You're like, oh my God, who's this new maths teacher who's just joined us? I cannot see. Oh, it's Mr. Brown. It's like Robin. I mean, what stupid is? That's Superman. Sorry, I'm off on it. Superman as well. All he does is he takes his glasses. Look, I've taken my glasses off. Did you not recognise me? Okay. If I did my head, if I shaved my head, if I did something, if I wore a hat, yeah. Do I look different? You're like thinking, oh, who's this? We used to have Mr. Brown. This is someone completely, it's like Clark Kent and Superman. I mean, the humans around these people, they're so silly as to not recognise it. Okay. Then you probably, Batman's got, you know, a good disguise, hasn't he? Anyway, let's move on. So look, if I say this is our question, this is our answer, why don't we just try and check that? Okay. How would you check that answer? Okay. No, I'm not going to do the 5-minute pause wait thing. I'm just going to get straight into it. Okay. We just go from right to left and we differentiate. Oh yes, we would, because this is a special video, and I just want to get differentiation in there as well. Okay. There we go. So why? Because a half e to the. My x's do that sometimes, don't they? It's my enthusiasm for words and x. Yeah, everyone loves an x. If you think about it, if you send an email to someone, you end it with X's, you're like, hey, it's quite nice. Send a text message to someone, it ends with X's, you're like, hey. Everyone loves an X for different reasons. Okay. But maths teachers love an X because it's about algebra. Half e to the x sine x minus cos x. Why don't we differentiate this and see what happens? Okay. You gonna do it with me? Are you gonna race me? Go. So u div dx. I'll tell you what, it's completely off if I speak, isn't it? So I won't. Okay. Did you beat me? I hope so. I hope so, because I gave you a break. Okay. We were on a break. Yeah, who's not my friends? Okay. I gave you a break, right? Because I wrote this line in here, which I didn't really need, if I'm honest. Okay. So we can see that half e to the x sine x plus half e to the x sine x is that, can't we? And you can see that half e to the x times negative cos x plus this, they cancel. Okay. But yeah, this is much quicker. I'm just demonstrating why. This answer is correct, because some of you would have been a bit sceptical, like, has he just cheated a little bit? Is that right? Is he just, you know, great thing about maths again, people, you can actually play around with the rules, not breaking them, but just sort of use them about different perspectives, okay? You've not yet, most of you, had an intuition question where you can just do that thing with the eye, see, and put it on the other side. other side. It's a lovely little technique. Okay. Yeah, and there are other little techniques like that. You don't always need them, but like Feynman's differentiation under the integral sign. I was reminded of that late last night. And yeah, it's a little trick that Feynman used. He's a physicist, by the way, to actually try and do some difficult integrations. Okay. Of course, there were easier methods than the one he used. I was about to say something nasty about physics, but I won't. Okay. Truth alert. I do love physics. Okay, I do love physics. Okay? Physics is great. It's not as good as maths. It's great. I just play around with it in class. I'm sure you realise that. Okay. How can a mathematician not like physics? Similarly, how can a physicist not like maths? The two do go hand in hand, don't they? Okay. But physics is always about applying it to the real world, isn't it? Yeah. Maths is about the purity of it all. Okay. Understanding why this works. Physicists don't have to understand why that works. They just have to apply it and use it. They want a formula and think, right, here's your answer. Okay. And right now there's a lot of applying maths going on, isn't there? If you go back to what's going on. So yeah, but people like me, we're just into the hardcore pure mathematics. So we do all the work, we prove all the theorems. Once all the theorems are proved, we can say to all the physicists, engineers, go ahead, go ahead, use it. Okay, use it. Anyway, there we go. That's that. Okay. Hope you like this extra special video, folks. Okay, made just for you. Okay. Bye bye. Stay safe. Always love maths. Okay. Take it easy.